The aim of this presentation is to introduce the concept of first ionisation energy. The first important question is, what is the definition of the term first ionisation energy? First ionisation energy can be represented by an equation like this. So if we just call X, any old atom, X gas, produces X plus gas plus E minus. So the first ionisation energy is the energy needed to remove 1 mole of electrons from 1 mole of gaseous atoms to produce 1 mole of ions, gaseous ions, with +1 charge each. So as a specific example, we could choose any old atom. Let's go for oxygen, O gas. That produces O plus gas plus E minus. So notice that this is always about removing 1 mole of electrons from 1 mole of atoms. So even though we would usually write O2 gas, in this case, the definition says it's got to be 1 mole of gaseous atoms. And even though oxygen would usually form O2 minus ions, in this case, this is representing the first ionisation energy, so we're producing O plus ions instead. So these are not necessarily the most stable forms of the ions in question. If we consider the features of the atom then, various features of the atom would influence the value of the first ionisation energy. So for the time being, let's use this model of the atom, where in the centre we've got the nucleus, so this is something that you're familiar with from GCSE, and here we've got electron shells or energy levels, like so, and the little circles here represent electrons, so an electron here. So the types of things that would influence how much energy is needed, remember, to convert 1 mole of gaseous atoms into 1 mole of gaseous ions with +1 charge each and 1 mole of electrons, will depend on the strength of attraction between the nucleus and the electron being removed. So the types of things that would influence that, firstly, would be the number of protons in the nucleus, i.e. the charge on that nucleus. Okay, so the charge on the nucleus. The second thing that would influence how difficult it is to remove that outer electron would be the distance between the nucleus and that outer electron being removed. And the final thing from this particular model would be the shielding. Now, shielding involves full shells of electrons between those outer electrons and inner electrons. So for instance, this would be 1 full shell, this could be a second full shell, and then we've got the outer shell in this particular example. So the shielding talks about how much that outer shell electron is being protected, if you like, from the nuclear charge. So shielding is by full shells between the electron being removed and the nucleus itself. So let's have a look at group 2 as an example of what happens to the first ionisation energy dropping down a group. So if we have a look at this group for group 2 here, hopefully you can see that there's a general decrease in first ionisation energy as we go down the group. So the first ionisation energy decreases down a group. Now, as you can see, the atomic number is increasing as we go across here. So the number of protons in the nucleus, or the nuclear charge, is increasing. which does not help to explain why it is easier to remove the outer electron, say here, than it is from this one here. So this explanation cannot rely on the number of protons because the nuclear charge is higher the further down the group, so that does not make sense. So what must be the case, going from the top to the bottom of the group for the explanation, is the following. As we drop down group 2, the atoms are getting bigger. So the distance between the nucleus and the outermost electron increases. Similarly, there are more shells, and therefore there are more shells between that outermost electron and that nucleus, so the shielding increases. And for those two reasons, less energy is needed to remove the electron because strength of attraction between the nucleus and the outermost electron decreases.